Hi guys, welcome back. This is chapter 10, the air quality chapter. We started this chapter the last time we met, but I'm just going to start at the beginning just to keep things a little more clear. So this is chapter 10 on air quality. I have my notes with me. If you guys want to fill in your notes as you go along, that would be great too. Here are learning objectives. There's a video that I can't really show through here, so I'll let you guys look at this video on your own. What this video was about, it was talking about a killer smog or deadly air pollution that happened in Donora, Pennsylvania back in 1948. It was coming from a zinc-smelting factory. Smog was common in the area, but weather conditions trapped the smog for days in what we call the temperature inversion. We'll talk about what that means. 20 became dead over the course of a weekend and thousands were ill, and this led to the Clean Air Act of 1967 and also the Air Pollution Act of 1955. So these are the streets of the smog. This photograph was taken at noon on October 29th in 1948. And again, this is in Donora, Pennsylvania. This happened from pollution that was coming from a smelting factory, which was providing the pollution for the smog. But again, the temperature, the air was trapping warm air beneath it so that the air couldn't be cleared out. Today, the streets have been cleared and there's no risk of deadly smog in the same town. So what is air quality and air pollution? These are your first two blanks under 10.1 in your notes. Air quality refers to the gases and small particles in the atmosphere that influence ecosystems or human well-being. And air pollution refers to the gases or particles that are high enough in concentrations to harm humans, organisms, and other structures. Gases and particles in the air, you can see nitrogen, oxygen, argon, they make over 99% of the atmosphere. That's another blank. The other 1% of gases are called trace gases. So when we're breathing in, we're actually breathing in majorly nitrogen and also oxygen and argon, but trace gases make up the other 1%. Some are stable, others can vary widely in where they're located, and they can be present in as little as parts per million, so extremely small quantities. This is a picture, someone riding through China where air pollution is incredibly terrible, wearing a mask over her face to protect herself, but unfortunately the small particles that can cause the greatest health risks are so small that the mask will do little to help that cyclist. This leads us to volatile organic compounds, abbreviated VOCs. This is number 3 in your notes under gases and particles. These are organic chemicals that can vaporize in the air. So they can be natural, like methane, or anthropogenic, which is man-made, like gasoline, paint, solvents, and automobile exhaust. Aerosols are tiny particles that can be suspended in the air. They can be solid or liquid. They can be in clouds and fog, and the size of the particle determines their residence time, meaning how long they'll stay around. This is a look at common aerosols: viruses, smoke, bacteria, dust, pollen, sea salt, algae, showing their particle radius, meaning how big they are in terms of their particle size. So pollen is on the larger size of those. So these are common aerosols, again, suspended particles in the air. We talk about sources of air pollution. This is under letter B. We can have a primary air pollutant or a secondary air pollutant. Primary air pollutants are chemicals directly released into the air, and secondary air pollutants are chemicals and particles that are formed by some sort of reaction of other chemicals or aerosols in the atmosphere. Photochemicals are specifically a type of secondary air pollutants whose formation is facilitated by sunlight. This is a look at how a secondary air pollutant might be formed. They give you the example of ozone, which is O3. That means they're just 3 oxygen molecules bonded together, and how it forms with UV radiation, taking nitric oxide, and volatile organic compound of oxygen to form that ozone. Then we look at point source and non-point sources of air pollution. Point sources are stationary localized sources such as smokestacks, so things that do not move that contribute air pollution to the skies. Non-point sources are ones that are able to be moved, so they can be mobile. Well, they can be mobile or stationary, but they're usually much more numerous in number that produce a much smaller quantity of air pollution. So an example of a non-point source would be cars or a residential fireplace. This is a picture of temperature inversion showing how the warm air above traps the cold air below it. So we get this temperature inversion pattern where the smog or pollution will be trapped near the ground. Here's a look at tall smokestacks being a source of point source, showing how as their emission increases with the height of their plumes or the smoke that's being delivered into the skies. So this takes us to 10.2, pollution in the stratosphere. There's no direct effect for human health. It can influence the climate though. We talked about this, how aerosols can actually cool the Earth's surface. Pollution in the stratosphere can alter sunlight reaching the Earth's surface. And this is where we talk about destruction of the ozone layer. Our ozone layer protects the Earth from UV radiation. And if we destroy the ozone layer will get more UV rays. The chlorofluorocarbons, CFCs, which are in some materials, they say can help lead to destruction of the ozone layer. Aerosols can cool the Earth's surface. This is a look at Kuwait oil wells burning for several months. The particles, the emissions from these fires disperse and actually have produced cooler temperatures over large parts of the Middle East. So some people think we should be pumping out more aerosols to try to help with global warming. I don't know if that's the best idea, but some scientists believe that. This is a look at ozone destruction, how ozone is formed. I'm going to skip over this slide. You don't need to know the chemistry behind this. This slide is interesting though because it's showing the ozone layer covering the North Pole. And as you can see from October 1980 to October 2016, you can see how the darker purple bluish area has increased in size. That means the blue purple, that's the depletion of the ozone layer hole that's growing in size. Pollution in the troposphere then, there's 3 types with the greatest impact on humans and ecosystems. And this takes us to your 3rd page of your notes under the 10.3 heading. First of all, the troposphere is the 9-mile thick layer of air nearest to the Earth's surface. It's constantly mixed by convection, wind currents. Acid deposition is number 1. That refers to the dispersion of acid-containing gases, aerosols, and rain. Number 2 refers to heavy metal pollution, which comes from anthropogenic or man-made sources, including the combustion of coal, metal smelting, and waste incineration. And number 3 refers to smog, which is a complex mixture of both primary and secondary pollutants. So let's talk a little bit more about acid deposition. Underneath acid deposition and heavy metals in your notes, I leave you 3 blanks, and you can just arbitrarily write down whatever you wish for these. Acid deposition can come down to the Earth's surface in the form of acid rain, acid snow, acid fog. It's an acid, so it has an increased acidity, so a lower pH, and this will alter the ability to uptake nutrients. So it'll allow toxic metals to go into the solution from sediments, such as aluminum. The primary sources of acid rain or acid deposition are sulfur dioxide and nitrogen oxide. And these will come from power plants, so some sort of plant that's creating something, and vehicle exhaust, so our cars. This is what acid rain can do. It can weather stones, so it can literally kind of melt away stones. Acid rains can also affect ecosystems. So acid deposition in this picture was a major factor in the death of these fir trees. This is a look at acid deposition in the United States. Rainfall has a lower pH, so that means it's more acidic near cities and industrial centers. So the large amounts of that sulfur dioxide and nitrogen oxide emitted from industrial facilities and utilities, you can see where the more acidic acid rain is in places like Illinois, Indiana, and Ohio, because those are coming from factories. Also other places along the East Coast where the big cities are. Heavy metal pollution, the big one, is mercury, which comes from fossil fuels. It normally is present in small amounts, whether that's from volcanoes, sea salt, and dust, but the concentrations of heavy metals have increased many-fold in the past 200 years, basically since the Industrial Revolution. When mercury is taken up by plants and animal tissues, the buildup, which is what we call bioaccumulation, the buildup of heavy metals in plants can damage their nervous system, and high enough levels can actually kill the plants and animal tissues. Here's a look at the mercury cycle. Nowadays, human activities are the most important source of mercury to the environment. Because mercury is taken up by plants and animals and stored in their tissues, they play a very important role in the cycling of mercury. A little more about heavy metal. Another one can be lead from fossil fuels, which can cause brain and kidney damage. This can disrupt how your hemoglobin carries oxygen in your blood, which is not good. And the amount of lead in the atmosphere came from increasing technology. So during the Industrial Revolution, we got more agriculture, smelting leaded gasoline. So now you'll see, many of you, when you go to the pump, gas is super cheap right now, you'll get unleaded gasoline. After the Clean Air Act was established in 1966, 1967, it banned the use of lead fuel. So after that, from here on out, every time you get gas, you'll see unleaded gasoline. This takes us to letter C, the smog, and there's a couple things you can fill in here from your notes. First of all, smog is a complex mix of primary and secondary pollutants. It can be industrial or photochemical. Industrial smog is your first blank under number 3 in your notes, and photochemical smog is the blank for number 4. Industrial smog usually comes from any sort of pollutant from coal burning or a factory, and photochemical smog is when certain primary pollutants will interact with sunlight. This usually happens from vehicle exhaust or your cars. This is a look at the 2008 Summer Olympics in Beijing, China. The Chinese officials took very dramatic steps to curb the release of both primary and secondary pollutants, so factories in the area were actually ordered to shut down in the weeks before the opening ceremony, and the use of private automobiles in the city was severely restricted just to try to clean the air before the Olympics. So the picture on the bottom showed that their devices worked, and they got a better, nicer, beautiful picture of where many of the Olympic Games were held. This is a look at reduced smog and how it's decreased over the years. And this is mainly due to the catalytic converters that have been required on all U.S. cars since 1986. And this has produced a significant decline in the levels of ozone and then the associated smog with that. We'll keep moving on then to air quality index. This takes up to the top of your next page of your notes. In most countries, regulatory agencies like the EPA set standards for acceptable levels of air pollutants. The EPA stands for the Environmental Protection Agency, so it monitors levels of important air pollutants. There's 1,000 sites in 300 cities. It's what calculates what we call the air quality index, and that's a measure of air health for each criterion pollutant. There's a 100 regulatory standard, and levels over 100 are considered unhealthy or code orange for sensitive groups such as elderly and children. Here are different types of pollutants, their threshold concentration. and how long they will last in the atmosphere, their duration. Under the U.S. Clean Air Act, the EPA set standards for these acceptable levels of 6 important pollutants. Note the particulate matter is subdivided by size, and these standards are defined in terms of exposure over a specific time duration. So if we were in class, I would ask you, what is the air quality index today? Since no one's driving their cars around, our air quality has been wonderful in LA. What factors likely contribute to the quality of air you breathe every day? Obviously, cars is a big one, exhaust, just pollution in general from all the people who live here. If you have any smokers in your home or light fires in your fireplace, that could also contribute to the quality of air you breathe. This is a fun website you can look at that shows the world's current air pollution and the current United States air quality. So let's move on to indoor air pollution. This is generally more polluted than outside air, which is hard to believe, but indoor air pollution, since you don't have wind and things to clear out the inside of your house, we have to be careful about what we're breathing inside our homes as well. Combustion byproducts can take the form of carbon monoxide, which is incredibly dangerous if you have a gas fireplace or a gas heater. Nitrogen and sulfur oxides, volatile organic compounds, and particulate matter. Indoor burning and secondhand smoke are 2 big ones that can contribute to indoor air pollution. These are deaths caused by indoor smoke. And this is the number of deaths per million of people per year. You can see it's really common in developing countries or third world countries. And this is because in these developing countries, many of them are cooking wood as a source of fuel for eating and heating their homes. And that wood smoke isn't being properly ventilated out of their homes. So this contributes to many deaths due to indoor smoke. This is a look at the most deadly indoor pollutant, and this is tobacco. So under your notes for indoor pollution, number 1 is that blank is just combustion byproducts. And the combustion byproducts include the carbon monoxide, things that are most common inside our homes, but in developing countries, most people cook and heat their homes with open fires. So that's what the graph we just showed was, how that kills approximately 4 million people per year because those smokes and fumes aren't properly ventilated. Tobacco then is number 4. The blank for number 4, tobacco smoke, is one of the most common indoor air pollutants, releasing more than 250 different toxic or cancer-causing gases and particles. So if for some reason you do smoke, please smoke outside your home. These are state laws regulating indoor smoking. So this has changed a lot over the years. As of 2017, 39 states had received a grade of C or above, and the grade reflects how well each state protects from toxic secondhand smoke in public places and workplaces. Some states still have an F letter grade. Alaska, Texas, some places in the South, that could be cultural. The people there, I don't know, might be hard for them to give up smoking indoors or further away from their workplaces. But it's great to see that state laws regulating indoor smoking has highly changed. And you guys might remember that, when we were kids, or when I was a kid, you would always ask for smoking or non-smoking in a restaurant. And now everywhere it's just non-smoking. No one can smoke inside anymore. This is something we would talk about if we were in class. Should e-cigarettes be regulated by smoking tobacco? This is a huge kind of issue that's going on right now, is more deaths are being connected to smoking e-cigarettes. It's on the rise in the United States. Many schools and governments are arguing that vaping should have regulations similar to smoking, but e-cigarette manufacturers promote smoking because it's low harm alternative to smoking tobacco. So my question for you that you can think about on your own is, do you think e-cigs should be regulated by other tobacco products? We're probably going in that direction, but who knows? Seeking solutions. So let's go on to this next part of your notes. Taking the fire out of cooking. So we talked about how smoke from indoor wood-fueled stoves is extremely common in developing countries. This can cause many health issues, including death. It can cause cancer of the lungs, respiratory infection, or other pulmonary diseases. Smokeless cooking fuels reduce this risk, but many are too expensive for these developing countries to get their hands on, like natural gas or kerosene. Some governments have tried to implement solar cooking, where they distribute a cooker that will only cook when it's connected to a solar panel. There's obviously pros and cons to that. This is a picture of kitchen pollution. Each day, the wood fire used by this family in Africa is used to heat water and food, but it also exposes them to considerable indoor air pollution because that smoke that's coming off of it isn't being properly ventilated. So this is really common in developing countries, to cook your food over a stove like this and also heat your homes like this. The search for firewood is a daily task for women in many countries. A lot of times women are given the tasks of doing this. So again, it comes kind of with female education that we can work on. Here's a look at what a solar cooker might look like. You can see how the sides of it are trapping the rays of the sun and then creating kind of an inside area that gets incredibly hot, as high as 100 degrees Celsius, which is pretty cool. Obviously, it won't work where there's not sun, but it's a good idea. Other indoor air pollution, I'm going to go to the top of your next page of your notes then, where it starts with number 3 and then a blank. Construction materials can cause or lead to indoor air pollution. Many can emit volatile organic compounds like paints, adhesives, synthetic fabrics, or wood preservatives. And asbestos, that's the blank to number 3, that's a fibrous material that is resistant to heat. So it's widely used in many buildings such as roofing and insulation. Breathing in these teeny tiny fibers can lead to lung disease and cancer. This was banned back in 1973, but if you live in a home older than that, and if you're doing any remodeling, just make sure you're wearing a heavy-duty mask if you're breathing in any of that insulation, because those asbestos fibers will cause lung cancer. So asbestos was often used to insulate pipes, and it can still be found in old buildings and homes. And again, the tiny fibers in asbestos can cause cancer in the breathing passages in the lungs. Radon is another form of air pollution. It binds to particulate matter. It decays to radioactive isotopes, which is not good. When inhaled, it can cause cancer. It's not significant outdoors, but indoor concentrations may be up to 1,000 times greater. So this is radon. So just be careful if you notice that something that you're using has radon in it. This is the geography of radon emissions. It's largely determined by the geological strata upon which homes are built. For example, dark brown indicates areas with large amounts of the rock basalt, which is rich in that element radon. So where do we not want to live? Kind of the Central Plains, North Dakota, are extremely high in radon. Pesticides, another indoor air pollution. This can be a wide range of toxic chemicals. Many of the pesticides we have used in the past are actually now banned today. These pesticides can get stored in the fatty tissues in the body, such as DDT. You can see some more listed there, which can lead to nervous and digestive system damage. Here's someone using indoor pesticides in the past, where potent pesticides were sprayed in homes with little attention to their possible effects on humans and their pets. Biological contaminants, this can be a buildup of any sort of virus, bacteria, or fungi, so some sort of microorganism that can pollute an indoor space. There was a 1976 outbreak of an unknown bacterium, and that called Legionnaire's disease. And Legionnaire's disease is the blank under number 2, under the biological contaminants section. It was a disease that was at the American Legion Convention. It sickened 220 individuals, killing 34 of them. So this was a bacteria, a good example of why we don't want a lot of buildup of bacteria and viruses in our homes. So this brings us to 10.5, what sort of policies have been in place to try to control air pollution. There's a couple I want you to focus on. The Air Pollution Act of 1955, these were standards set by different states. And the big one that you have a blank next to is the 1963 Clean Air Act. This regulated emissions from stationary sources, such as factories and power plants. So incredibly important when Congress empowered the EPA to determine the best technologies for controlling these pollutants. Many people protested for these changes. This is following a deadly smog event in 1954, which actually occurred in Los Angeles. I'm not familiar with it. Maybe some of you are. These women were protesting for air quality laws and the creation of an agency to control the smog. More air pollution policy and law. There's international air pollution policies, agreement to limit air pollution among countries. And this is driven by a shared sense of need and cost sharing. So you have a blank there under letter A. It's the Geneva Convention on Long-Range Transboundary Air Pollution in 1983. And this was one of these international corporations which tried to reduce air pollution internationally, which is cool to see countries working together to try to reduce air pollution. This is United States sulfur dioxide pollution. The concentration of SO2 has been declining since 1970, but the implementation of the sulfur cap and trade program set up by the 1990 Clean Air Act has caused the decline to accelerate even more. So this is just good to see. This is on the y-axis, it's showing concentrations of SO2 and how it's been declining since the 1990 Clean Air Act. International air policy and pollution, there was a 1999 protocol that addressed acidification, eutrophication, and ground level ozone, and then a Montreal protocol on ozone, which also aimed to reduce ozone destruction of the ozone layer. This is our last slide, just showing how CFC emissions have also declined over the years. And again, CFC, often a product of aerosol cans, is one product that they said led to the destruction of the ozone layer. Thanks for listening, guys. This is the end of Chapter 10 on air pollution.